Yeah, hello everyone. Welcome to the session. Our interviewer is not keeping well. So both the interviewees will play the role of interviewer and interviewee. So let's get started. We have had amazing sessions until now, wherein we understood about the details on what kind of questions people might ask in interviews and how you are expected to respond to those. And today we are going to talk about data mining supervised learning algorithm. And within that, we are going to talk about KNN, K nearest neighbors. So I'll get started with the first question. So Sharath, what is the difference between K-means algorithm and KNN algorithm? Over to you.
Hey, good evening. Good evening, Bernie. Good evening, everyone. And welcome to the channel. Yeah, I was expecting that question because this is one of the very common questions that interviewers generally come up with to understand how the students or how the interviewees are basically understanding the subject. This is a very basic, important question that you need to look at. So to answer the question, K-means is a clustering algorithm, which is an unsupervised learning technique. And in this case, our dataset will not have labels. That means we are only dealing with input variable predictors, or you can say factors or features or attributes, but labels are not there. Whereas if my dataset also has labels, then I will be able to do predictive analytics on top of the data. And I'll try to classify new records into one of these labels. This becomes supervised learning technique. And your KNN algorithm is an extension to clustering algorithm, you can say, which runs on the distance-based concept. And yes, the primary difference is unsupervised learning, and KNN is supervised learning.
Wonderful. Yeah. So one more question is KNN a parametric model or non-parametric model? And why is it called in that way?
Okay. The algorithm, the KNN algorithm, does not store or does not learn any pattern in each iteration. Right? So it is called as a non-parametric algorithm because it's not learning anything. Every time we try to do the prediction, it uses the distance concept, and then based on the similarity, it tries to predict. Right? So it's not recording any parameters for using those parameters for predictions. That's the answer. It's non-parametric algorithm.
All right. And within KNN, how do you decide on what is the K value supposed to be?
Yes, Vani. So let me share my screen here. And this is the cheat sheet, you can say, which is specifically done for only K-neighbors classifier. But if I have to talk about the K-nearest neighbor algorithm, then I would basically say that it can be used for both classification as well as regression. That means your KNN algorithm can solve non-numeric output problems and numeric output problems as well. This is the first point. The second point that we need to also remember is every algorithm has certain parameters which will allow us to tune the performance of that particular algorithm. In KNN, as the name itself says, K is the number of nearest values to the record. If I have to classify this new record into one of the output categories, then we are going to look at the similarities of this record with respect to the existing historical records. Now, in this scenario, how many closest points should we consider is the hyperparameter that we need to choose. There are certain conditions that we need to look at whenever we talk about classification model, that is when we are trying to define non-numeric values. Then KNN method goes with majority. That means mode concept. This is the first point. And when it is able to get the majority, fine, it's very easy to predict that. But if you're not able to get majority, for example, if I have a two-class problem, that means it's a binary problem, then I cannot choose k is equals to 2 or any number which is even, multiples of 2. If I do so, then I might get the closest records which are equally distributed. That means if I have 1 and 0, then I might have one record which is closer to the record, new record, will be from the class 1, and the other record that we have will be from class 0. So this is an ambiguity scenario. So this is one problem that we will have to address. So as a developer, when you're writing your code, KNN algorithm, you need ensure that you don't choose k value, which is multiples of your classes, the number of classes that you have. So not equal to the number of classes, multiples of number of classes. This way, you don't get into the ambiguity scenario and you will get majority. If it is a numeric problem, then depending on the nearest values, it chooses mean value, and based on that mean, it tries to predict for the new record. How to choose the best k? It is an iterative exercise. We will have to try with different k values, try to fit the data with respect to the k, try to do the prediction, capture your metrics, and then identify at which k value we are getting the good performance. And always remember, when we talk about metrics, a lot of participants, a lot of newbies in the machine learning world, they always redefine accuracy only. By default, they fall back to accuracy calculation, but always remember, this is not the only parameter. You'll also have to look at the misclassification cases as well, right? And you need to assess the cost of misclassification for each k value that we are trying to measure. Along with accuracy, we also have to look at false positives and false negative cases, assess in what scenario the application can be more practically applied to the business cases, and then choose that respective k value for deploying it onto the production instance. So it's an iterative experiment-based approach, and we can always do automation on hyperparameter optimization. You can use grid search, randomized search, or your Bayesian search. Different search algorithms can be, hyperparameter search algorithms can be used. You can also manually write a for loop for that matter, and then sequentially you keep executing the k with those respective neighbors, and then try and see at what k value you're getting good results. So that's about choosing the k value. And of course, along the way, we'll also try and do other parameter alterations as well. Bunny, you're on mute.
Yeah, I was just checking whether you were active or not, sir, as an interview. So that skill is also very important to be active. Okay, Sai Chendu has a question on LinkedIn. What is dimensionality reduction technique? And what do you mean by underfitting and overfitting? These two questions are slightly off track with respect to KNN. We will answer that towards the end, certainly. And in the interim.
Yeah, maybe, Bernie, we can also direct Sai Chendu to the video there in the series where we discussed about dimension reduction specific topic. So Sai Chendu, I would recommend you to go to that particular topic in the series, and you should probably be able to get all those details.
Yeah, absolutely. Well said. Well said. So there are a couple of videos which we have, one on dimensionality reduction, another on the entire machine learning pipeline, not machine learning pipeline, I would say machine learning primer for that case. So both of those will be shared by our team to you, and you might want to reap benefits on that. So the next question pertaining to KNN is, this KNN algorithm is called as lazy learner, like a lot of students, right, Sharad? So why is it called as lazy learning algorithm?
Yeah,
And
like
yeah, like me as well.
yeah, it's always said that lazy people are more smarter. So yeah, I would be taking that as a compliment.
You're lazier than me, that is.
Well, so it's not just lazy learner that is the name that is given to KNN algorithm. It is also called as memory-based reasoning, example-based, instance-based, case-based reasoning, or rote learning, right? So these are all different names. Of course, the lazy learner is more popular with respect to the catchy words and easy understanding, easy interpretation. This is because, as I mentioned, KNN algorithm is not recording the learning process. Whatever we are trying to train on the historical data, it is not trying to learn the pattern. It just does the distance calculations. And whenever we ask a question to the algorithm, it takes the distances and then gives the results. Unless until we measure the distances, when we predict, only then the calculations happen. Until then, it waits. And this basically puts a lot of computation burden when you have larger data sets. Now imagine the distances would have been stored, calculated and stored with respect to your historical data, right? Now, if that would be the scenario, then distances would be readily available. And when you ask the question with respect to that record, it would probably be very easy for the algorithm to return the most similar records. But that is not the case in KNN. It is not built that way. Whenever new record comes in, only then the distances can be calculated. And only after distances are calculated, we will be able to identify the shortest distances, and then we will be able to tell whether what is the class of that particular new record. So that is the reason why it is called as a lazy learner.
All right. So well said, Sharad. So the next question is, what are the various hyperparameters within KNN? And if you may let us know, what is the single most important hyperparameter which people have to apply on the projects? What would that be?
All right. So if you go to the official documentation of sklearn neighbors, the k-neighbors classifier, that is the library of the function that we are going to apply when we want to implement KNN algorithm, you can see the bunch of parameters which are defined for the algorithm. And n neighbors, this is explained here, n neighbors is the number of nearest records, right? So the number of neighbors, which are basically closest. This is the single most mandatory, I would say, like a parameter for your KNN algorithm. You can have rest of the parameters as the default parameters, but n neighbors is something that you'll have to play around. So if you ask me how do you tune KNN algorithm, I would say the default choice is n neighbors. But again, saying that, we can also try and do the hyperparameter tuning with respect to all the other parameters. You can also choose the distance metric that you are trying to apply. You can also have the weighted average, where you can also use weight function. It could be uniform function or distance-based implementation can be done, right? So any other user-defined functions can be also used here in the weights. Then the algorithm that we are using for measuring the nearest neighbors, compute the nearest neighbors, can also be altered. By default, it is auto. You can say this is like Euclidean distance, for example. So on and so forth, we have other bunch of options. And if you have a distributed environment where you have multiple processors, then you can also use n jobs to ensure that the distance calculations that the algorithm is doing can be done parallelly. This would speed up the performance of your entire algorithm. So this is the list of your hyperparameters. But as I said, n neighbors would be the utmost important parameter that we need to play around.
Sure. Yeah. Okay. And Sharad, whenever we build any algorithm, predictive modeling algorithm, we should think about whether the model is overfitting or underfitting. And then we need to make use of regularization techniques, using which you can ensure that your model is a right fit model. How do you deal with this? And you can elaborate on how you determine whether your model is overfitting or underfitting, and how do you, or what is the regularization parameter that you would consider to ensure that you get a model which is right fit?
Yes. So when you talk about model evaluation, then we are basically trying to measure the performance of the model, right? You need to evaluate whatever the model that you're training to start with. And just now we discussed that n neighbors is the parameter which we try to tune so that it gives us good performance. Now, I would try and explain the simple psychology of any machine learning model development. What we need is a machine learning model which can give us a perfect result. That means your output variable that you're predicting should be equal to your actual value. And we try to tune the algorithm until we reach that best accuracy. Theoretically, that best accuracy is nothing but your actual output. That means accuracy should be 100%. But when we try to do this, the problem is the algorithm may try to get used or get trained on the training data set alone. It tries to adjust itself so that it gives you 100% on the training data set. This scenario is called as overfitting. Now, for example, you are a student and you're learning some subject. There's a question that is coming up and your lecturer, professor, is not going to give you 100% marks if you are making even a small spelling mistake. Forget about the subject. So forget about the knowledge that you are learning from that particular question and answer scenario. But your professor says, I need perfect answer. So in such case, you might probably become a Xerox machine and then copy the answer and paste it there. But that doesn't mean you're learning the subject, right? Copy paste is something which is not good. So your overfitting models will give you perfect results on the training data set. But it does not mean it understood the pattern or it is generalizing the problem statement that we are trying to solve. So when you try to give some new data point, it could be from your test data set or validation data set, could be from historical data. When you give some new data point, the model will not perform well. It may not give you even a close to 100%. Forget about 100%. It may not even give you 60-70% of accuracy in those cases. These scenarios are called as overfitting. So in simple terms, machine learning model, when it is verified on training data set, it gives us very good accuracy. But when I try to verify on test data set, the results on the test data set will be very low accuracy. This condition is called as overfitting. Now, what we need is a model which can be generalized. When I say generalized, if the data is coming from this particular business case, if it follows specific pattern, then even on new data, the algorithm should give us consistent results. That means the training data set accuracy should be decent, good enough, and test data set accuracy should also be good and similar to the training data set accuracy. If this consistency is there, then I can say, yes, the algorithm has learned the pattern hidden in the data set, and it is now in a position to solve the business problems. So on new data set, it will be able to predict the results appropriately. So always compare training accuracy and test accuracy.
Sure. Yeah. And so, Sharath, you're saying that K value, which is a hyperparameter, also happens to be a regularization technique, which is
Absolutely.
used to do a variance and bias trade-off. Variance is overfitting, bias is underfitting, and then we will be able to get the right fit model by playing around with K value, by changing the K value. Okay.
Exactly, that's correct.
Yeah. So next question. Yeah.
Sorry. Yeah.
Sure. The next question is, what do you think will be the range of this K value? What is the minimum K value going to be, and what is the maximum K value going to be?
All right. Yeah. Another very important question. When we talk about N neighbors, we call it as K friends. So don't get confused there. We're using the terminology K. It's nothing but neighbors. If I have N records in my training data set, assume that I'm looking into a two-dimensional data. That means I'll have X1, X2, and output label data. So if I'm trying to project this two-dimensional data on a visualization, X-axis and Y-axis, then you will be able to see the data like this. Okay, so this is my N records. I'm projecting that. So when new record is given, new data point is coming into the picture, then it is the distances that we have to calculate, and based on distances, we will have to try to predict the outcome. If I have N records, can I calculate N plus 1 distances? Obviously, no, not possible. So the maximum K value that I can take is equal to this data set size. All right, so this is your max, I would say N. Now coming to the minimum side, you need to have at least one neighbor, right? You cannot take 0 neighbors and try to predict it. So minimum value would be N, 1. So K can range from 1 to N, where N is the data set, training data set size.
Sure. I think there is a question on our YouTube channel, and question is from Tejas. His question is, can you talk about KNN imputation? And another question is KNN from Shiv Kumar? This question is from Shiv Kumar. Is KNN non-parametric?
Yes, I think we have addressed that question. Yes,
Yeah.
KNN is a non-parametric algorithm because it doesn't have any coefficients which it records.
Absolutely.
The second question. Sorry.
KNN imputation. Yeah. Can I take that?
Yeah, absolutely, Ben. Please go ahead.
So friends, if you have a specific data set in which you have your output variable, and say you have a bunch of input variables, okay, and then say you have a column called age, say you have another column called income, and age is 32, income is $10,000, 28, $8,000, so on and so forth, and say one value is missing here, one value is missing there, etc. Okay, so within KNN imputation, if you choose a K value to be, say, 10, for example, obviously what will happen? It will choose the 10 nearest neighbors, 10 observations which are very close, and it would take those 10 values and then take an average of that. So if, say, observation number 1, observation number 10, observation number 15, observation number 100, so on and so forth, in that way, are the 10 nearest values to this observation where you have a value missing. So after it takes all of these 10 nearest neighbors based on distance, it will take the age of all those 10 observations and then take an average of that. That is what would be imputed here, replaced with the missing value. And if you have a categorical variable such as gender or education, and if you have an observation or a value missing in a specific observation, then if you do k equal to 10, 10 nearest neighbors, 10 nearest values to this specific observation where the value is missing would be calculated. And then based on all those 10, you take the majority, that is the mode, and then perform the imputation. Simple. This is KNN imputation. It acts in a very similar fashion to that of mean or mode imputation. Mode when you have categorical data, mean when you have numeric data. But the point here is that when you do a mean imputation or mode imputation, you look at the entire data set. But when you do KNN, and if you say k equal to 10, only the 10 nearest neighbors are selected. And you take that variable, which is numeric, and then take an average and replace this missing value with the average. If you have categorical, then you take the 10 nearest values and take the mode of that and replace. Yeah, that is how you deal with KNN imputation. Okay.
May I add a point, Bernie?
Yeah, please, Sharad, go ahead. Sharad wants to add a point.
Yeah, friends, whenever you talk about this KNN imputation or regression-based imputations, right? So these imputation techniques are nothing but prediction-based techniques. So whichever field that you are trying to impute, you treat that as new record, consider all the records which have 100% data, treat that as training data, build an algorithm, whatever algorithm you want. In this case, we are using KNN algorithm. And then once the algorithm is defined, you pass this missing fields into that algorithm and try to do the prediction. Right? So that's all. It can be KNN algorithm or any other algorithm. Ultimately, you're trying to find missing values using prediction techniques.
All right. Yeah. Thank you. Thank you so much, Sharad, for that. And I think since K-means is not used, Bhushan, because K-means is unsupervised learning algorithm. It is used for clustering. It's a different thing altogether. So certainly cannot be used. And yeah, we changed the K value, Kumar. Yes, absolutely. All right, friends. So you can refer to our mind map on website. You can refer to the cheat sheets section under learning resources to get better access to the literature and content that we are trying to create. Thank you so much. Please share this with as many people as possible so that they get benefited and we get value for the effort that we are putting into these videos. Thank you all so much and all the best for your career.
Good night, friends. Thank you. Happy learning.